All right. Oops, I think someone's on not on mute there. I'm just gonna mute Tam, I think. Okay, cool. All right, hey everyone. Just a very warm welcome to all of you for joining us for Demo Day. Very excited to have you here, and very excited for the students to showcase their capstone projects to all of you. The agenda we're going to be walking through today is we're going to kick off with a quick introduction to the bootcamp for those who are not yet aware of what the bootcamp is and what the students have done over the course of 16 weeks. Then we're going to jump into the meat of today's event, which is the capstone project presentations. And towards the end, we will have a bit of time for networking as well, and with some pretty interesting discussion topics as well for us to chat about together. All right, so first and foremost, I just want to say a massive congratulations to the bootcamp participants. You've endured 16 weeks. You've made it to the end. 16 weeks is a long time, and I know many of you have given up, early mornings or late evenings for some of you to complete the bootcamp. So kudos to you on that. A bit about the bootcamp participants. So the participants doing the bootcamp are from around the world. From places like Australia, Singapore, India, Europe, different parts in the US as well, and places like Chile as well. So yeah, it's a really diverse bunch of students, and they come from really diverse backgrounds and careers as well. So all the participants are employed and they are working in different jobs, and they work at companies ranging from places like Apple, we have Eric here from Apple, and different companies as well, like Atlassian, Visa, and so on. So who are the instructors teaching the bootcamp? So you have myself, John, who is an instructor in the bootcamp. And I'm also a data engineer working at Canva. We have Hengji Liu, who is also an instructor and a data engineer at Canva. We have Pavan, who is an instructor and also a data engineer at Deloitte. And we have Douglas Robertson, who is a career services officer and the director of the recruitment services. So that is to say that the instructors of the bootcamp are all experienced and also practicing data engineers and professionals. Cool. So what have the students learned over the past 16 weeks? So over the 16 weeks, we've covered topics ranging from data engineering fundamentals like Python, SQL, AWS, Docker, and moving on to tools and frameworks like data integration with Airbyte, data warehousing with Snowflake DBT, data modeling, touching topics like dimensional modeling, one big table modeling, and semantic layer with preset, Lakehouse with Databricks Spark, Great Expectations, and Delta Lake, data orchestration with Airflow, real-time stream processing with Kafka and Clickhouse, CI/CD and infrastructure as code with GitHub Actions and Terraform. So we cover a wide range of topics, ranging from beginner topics or introductory topics all the way through to the advanced topics as well. The next cohort is going to be kicking off on the 31st of July, which is in 2 months, two and a half months time, I should say. We have capped the seats to a limit of 30 seats, and we currently have filled 18 out of the 30 seats, with 12 remaining. So if you are interested in enrolling, do drop us a message on dataengineercamp.com. Feel free to share it with your friends as well who might be interested. All right, so without further ado, we're going to dive right into the project presentations now. We have 3 presenters up for today. We have Eric, Gernot, and Marc. And the format for today's presentations is a 10 to 12, maybe even 15 minutes presentation. If it goes on for a bit longer, that's okay. And then towards the end, we will also have a 3 to 5 minutes Q&A time. So if you have any questions that you'd like to ask the students, any clarifications, any thought-provoking questions you'd like to ask, feel free to jump in. You can drop your questions as well in the chat along the way of the presentation, and I will kind of facilitate and make sure that your questions get answered as well. But also, if you'd like to give feedback to our bootcamp participants, feel free to do so. Our participants are here to learn as well. So if you have any feedback on things they could do to improve in the future, do let them know as well. That's greatly appreciated. All right, enough of me talking. Without further ado, I'm going to invite Eric up to present his presentation.
Hey, everyone. Thank you for having me here today. I'm really excited to be able to take a few minutes and walk everyone through what I've been working on the last just week or two, and just some of the concepts that I've been able to learn throughout this boot camp. I'll give you a little bit about me. First off, like Jonathan mentioned, I do work at Apple in a non-technical role, sort of just in project planning, and I love to learn things on the side. I've been doing that for the last during the boot camp. It's been a long journey, but so worth it in the end. I just for me, just honestly, I love being able to go through life and have moments where I'm able to learn something that's very challenging, such as data engineering, and be able to come out looking back saying, wow, like I learned so much throughout this time. So yeah, I'll go ahead and get started, and then if you have any questions at the end, feel free to chat, or any feedback. Love to hear that. So yeah, I did a project a little bit different than maybe some of the previous projects that I've worked on. I specifically picked my data set based around my interests. So I love playing online chess. So there's this website called Lichess, and one of the cool things about Lichess is that it's an open source and it's also a nonprofit. So compared to other sites out there that host chess games, Lichess is free and also open source, which is a great option for a data engineering project because they have a great API as well. To give you an idea of their scale, they do around 100 million games. They host around 100 million games per month, as well as total across their lifespan, across, let's say, the last 10 years or so, they've hosted over 4 billion games. So serious scale when it comes to storing data. And some interesting pieces that I learned maybe a little bit too late into my project, but the API limitations are that I can pull about 20 games per second. I get the JSON data from that, and that I can only do one request at a time. So I'll go right into my data path here. So basically going through what my project includes, what it doesn't include, and some of the cool pieces surrounding it. So I'll just lead you through each piece here. So on the left, you'll be able to see that I'm pulling from my Lichess API. And the way I'm doing that is I created a custom producer, which is a Confluent custom producer with Kafka that gets the data from the API and puts it into a Confluent topic. And then I have a Confluent hosted created connector that takes the data from that topic and puts it into Snowflake, into my raw data table. So the reason for this is, compared to using something that Confluent had on their own, is that I wanted the ability to pull many usernames in a variety of data with one connector, rather than having to create 40 connectors on Confluent, which just didn't seem feasible. So I opted for the route of hosting my custom producer inside of a Dockerized image that I host on AWS. My current system is I have it running at once a day, and then an hour later I have my DBT project, which I will get into in a minute here. I have my raw data that's coming in JSON, and then I parse that JSON and do some transformations on that to make it so I have everything in the proper format to be able to then make some dimensional models. So I opted for dimensional modeling because I felt that it would help me in the event that I want to visualize the data. Unfortunately, in the end, my Tableau trial expired, so I had to go for something like Preset, which doesn't support dimensional modeling. But regardless of the fact, the dimensional model would work and still is really, really great, because I did test in a Tableau originally. But I also created a one big table to use in Preset. In order to actually do all these dimensional models and transformations, I'm using DBT, which is hosted on AWS and ran through ECS. It's Dockerized and put it inside of a repo in AWS. So, and then I visualize this data in Preset. So in my DBT, the lineage I have is that I basically am just creating these dimensional models and then creating a one big table at the end in order to combine everything together after I've done my transformations. This is just a quick look at my dimensional model. So some key things to take a look at is that I have a key in each of them to be able to link back to my fact table, which is the process that I'm basically trying to model here is just the game itself. And a few of the pieces that I really wanted to be able to take out of this is I wanted to be able to understand the opening of a player that I really admire. So a player whose name is Andrew Tang. He's a grandmaster and he plays a lot in lead chess. He's #1 in multiple categories, and he's known for playing very fast chess. So I really enjoy that as a hobby of mine, but I wanted to be able to dig a little deeper and understand his win rate with different openings, as well as be able to go into those openings and learn them on my own. So the dim opening here is a really important piece for me to be able to actually connect the ELO, which is basically just the rating system of a particular person on the site, as well as their openings. I also use preset to visualize this, which I connected directly with Snowflake. And the nice part about this is that it actually allows me to refresh the data whenever I want, and it refreshes in real time to my dimensional models. So I think that's one really cool piece about this, is that I can actually do it in real time, make some edits, and see that data sync through all the way to preset, which has been really cool to test out. So the end dashboard that I created, just something really simple with the data that I had. This is a dashboard of Andrew Tang's win rate, as well as his the amount of games he played in the last couple of years. So you can see in one of the visualizations here is that he plays queen pawn game very often, as well as does a variety of defenses, such as the French defense or the Indian defense very often. As well as we can see he's remained sort of at the top of lead chess rankings for a pretty long time. So it doesn't mean quite as much, but the cool thing about this visualization is that I'm able to take different users and be able to do the same visualization with them by just changing a few things. So for me, I'm able to see my rating and my win rate, which is really cool to be able to just see how I compare to someone like Andrew Tang, who's just a complete master in the field. Yeah, I have a few pieces here with the ability to see how often he plays, or the top 10 openings he has, as well as his current win rate. I can't show you here. I'll show you my demo, but this win rate is just his win rate on a daily basis. So currently, when I took this screenshot, it was 85%, which is extremely high for a chess win rate. So yeah, that's some of the pieces of the project. I wanted to go into just a quick lessons learned before I go into a quick demo of the dimensional modeling, which I'll just run through my AWS. Yeah, I mean, so I learned a lot from this project. One of the most notable pieces for me is that understanding how data is going to be used in the end is very important to your beginning steps of creating the project. So for me, this application comes down to, in the future, and as I look to get into a data engineering job, something as simple as like a meeting with your stakeholders or early demo with your stakeholders goes a long way into making sure that what you're building actually gets there. In the end, in this project, it was me that didn't understand what I was really wanting in the end at the beginning. So that was a great little lesson learned. But also establishing good naming conventions at the beginning and style, because it's very hard to change those things midway through after you've built many models to be able to, using these, let's say, subpar naming conventions. It's harder to change them after the fact. So starting early is really great lesson learned for me, as well as just understanding the data set that you're pulling from, being able to take a long time to to really understand the docs in order for you to make really good decisions. I don't know if I would have chosen this API in the end if I spent more time in the beginning, just because it limited my ability to do like a streaming project or sign-outs based on the limitation of the polling rate. I'm just going to go into a quick. I'm just going to go into the demo. So let me just go ahead and go over to my slides. Okay. So first, I want to go ahead and just see here. So I just want to quickly show you as well. This is Andrew Tang. He's the GM that I really admire, and who's one of the motivating factors for me to be able to do this project. He's really known for something as crazy as bullet and hyperbullet, which is each side someone has 30 seconds or a minute, which is extremely fast chess. But I'll go ahead and show you a few of the pieces here. So first and foremost, I have 2 repos on my Amazon ECR service, which basically host both my producer as well as my DBT project. So I'm going to go ahead and show you my Snowflake as well. And let's go ahead and do this. Okay. So I'm going to go ahead and start my run on my, I want to first just go ahead and show you, I basically am running these things on a cron schedule that go every single day at 12 a.m. And then I have the producer running at 12 a.m. and then I have my DBT project running an hour after that. So if I go ahead here and run a manual task just for the sake of the demonstration, I'm going to select my task family and my task, and I'll go ahead and get that started. And in a minute here, I can also show you the logs that come up from that. To take a minute and show you my the way my Snowflake database is set up. So I have 3 schemas that I primarily use for this, which is I have my raw data schema that I can't really demo my my producer at the moment because of the fact that it takes so long to actually get all the data due to the polling rate. But basically I get the data inside of this format that is the custom topic inside of the in JSON data, and then I stage this data by splitting it up into all these columns in order to out of the JSON, and as well as I really clean up a whole lot, because taking the data straight out of JSON really puts into a place that really is not good. So I had to clean the data a lot with a couple queries. And then in the end, I have a couple tables here that are my dimensional modeling tables. So I have keys that rotate back, and I used DBT utilities to be able to do that. And then I have the all of them here. I'll go ahead and show you my logs from it. So basically, I'm just running all my models through a DBT run on this in AWS, which just in the end, it just works out, and I can have this the final dashboard where I can really take a look and dig deeper into the win rate over time to understand patterns, and then be able to really see what openings I should really be spending my time on into the future. So yeah, that's just a little bit about my project. I appreciate the opportunity to share it. I opted for something less complex as my final, but if you knew this place that I started from at the beginning of the bootcamp, I think I'm really, really happy with how far I've been able to come. So yeah, thank you for your time, and any questions or comments or feedback would be greatly appreciated.
Awesome. Round of applause for Eric, everyone. Good job. Yeah, as Eric said, now it's time for questions. If you have any questions or feedback you'd like to give, feel free to either unmute yourself or feel free to drop your questions and feedback in the chat.
I have a quick question for Eric. First of all, great job, Eric. This was good to visualize what the process is like. So I just have a quick question. As you mentioned, the opening, I'm not sure what opening exactly means, but my understanding is it's the first step essentially in the chess game, in the game of chess. But I mean, the moving of the first.
Yeah, so basically the opening in chess is usually going to be, it can be a lot of moves, but normally it's going to be a shorter amount of moves that are, let's say, chess openings have been run for with data, with like machine learning to figure out what is a perfect set of moves for it to for a particular opening, which is, let's say, the first 5 moves or 10 moves. And you get this idea, which is called opening theory, where someone wants to follow opening theory because it's known to be the best opening. And then chess basically has this this database, or this table that is all the names for it based on the creators, the people that discovered them. And then each one has nowadays been run through tons and tons of computers to figure out which one has this particular best win rate. But ultimately, at the end of the day, everyone's going to do better or worse with different openings. But yeah, it's just basically the first set of moves inside of a game.
Cool. The only question I have regarding that is, suppose there are 2 or more players having same set of openings essentially, but they have different win rates. So how difficult would be for your current implementation to, or how would you change the implementation so that instead of the openings, it's the moves in the middle of the game which you need to set in this dashboard? If you understand my question, if I'm able to explain my question here.
Yeah, I get what you mean. The hard part is that it's all exponential when it comes to chess. So for every move that's made, there's like millions upon millions of combinations. So I don't know if I would be able to, with my current implementation, to be able to like make any meaningful discoveries out of that with my current implementation. But I've considered doing a type of table that is, I forgot the name of it, but basically it would be able to split the opening past maybe base opening, because they have a base opening and then they have variations that stretch all the way to, let's say, 10 moves or plus. But yeah, middle game, I wouldn't be able to really visualize too well. The thing I would be able to do is if every single game had a chess engine run on it, which is an option on the site, I would be able to map how accurate someone's moves are across a game. But I didn't get the chance to do that in this implementation, but it is something that definitely is possible to be able to say, what is how close is this someone to a computer's move, which is called cent upon loss. And that can be tracked across a game. Yeah.
Awesome. Thank you very much. Great job again.
Yeah. Thank you. Appreciate your question.
Eric, one quick question. So what's the rationale behind using Snowflake here?
Yeah. So I ended up deciding to use Snowflake. First and foremost, so I found it to be really easy to connect to. Just on a practical level, I found it really easy to connect to, as well as it gave me the ability to split up my project into schemas really easily. Besides that, the scale of my current project doesn't require, Snowflake specifically for the scale. But if I was wanting to scale this up to, 40 people across the history of their games, which is originally what I was really wanting to do, but with the limitation of the API, I had to scale it back. That's really what I was thinking with Snowflake, because Snowflake's able to really handle that and optimize the queries in a really, really great way. So that was my original intention with Snowflake, as well as it integrates really well with DBT, which is how I really want to run my models. So yeah, I would say the optimization as well as, learning more about it.
That makes sense. Thanks. Yeah, I just wanted to point out that maybe Redshift is also parallelly an equivalent option that you can consider as well.
Definitely, yeah, that's a great call out. I think for this particular project, it could go either way, like you're saying, definitely.
Yes, totally agree. Thanks, Eric. Great job in the presentation, and overall looks very good end to end, the explanation and how the architecture turned out.
Thank you so much. I really appreciate it. I see a question in the chat. The language, the way I ended up parsing the data was just in SQL queries, which is basically mapping the different columns to new columns and basically splitting it up that way. So I ended up doing it in Snowflake through a DBT model, a staging model, which I should be able to show a little bit of it. But let me show here. It's a little complex, and I would have loved to split this up more.
Sorry,
but
you're sharing the other screen.
Yeah, I'll go ahead and drag this over. So it's a little crazy to look at. I'll give it to you there. But basically, I'm trimming these different tables in the way that I need, as well as mapping the columns in JSON to new columns, as well as deduplicating. So I have this staging table that I ended up going through. So that's the way I go ahead and do it. Yeah.
Yeah, the columns are probably the main thing. Like that's how you drew into key value pairs.
Right.
And not every SQL database language will support that, but I think SQL Express does, for example.
Yeah, it actually was easier than I had thought using SQL queries rather than having to write out a program to do that. I can also just give a quick show of my my custom producer, which basically this particular producer would be able to handle any type of entity names. If the pulling rate of the API was any faster, I would be able to basically just loop through a list of these names, and it would be able to pull all the data from it. So yeah, I think I don't want to take much more time, but I really appreciate the opportunity to share. Awesome.
Well, if there's no other questions, then we'll leave it there. Thank you so much, Eric. That's awesome. Round of applause again for your presentation. Awesome. Good stuff. All right. Next up, thanks, Eric, again. Next up, we have Gernot for his presentation. So Gernot, if you'd like to go ahead and share your screen.
First, I try to unmute myself, right? Thanks. Thank you guys for having me tonight, today, in the evening or in the morning. Yeah, that already is the introduction that DBC has become a global phenomenon, I think. So thanks again for the opportunity to present the DBC Capstone project, which is, as you might recall, it's the third project we had to do during the DBC project or DBC tour. My one, or first a little bit of background. So I'm a trained research scientist coming from life science. So in that neurobiology and brain research. And I'm currently working on my own company and conduct data science projects for other companies and doing digital research, including user research for new products and new services. And I wanted to broaden my scope, and therefore I end up in DBC to broaden my capabilities in terms of data engineering. And it was a super great ride so far. And yeah, and today I would like to bring you something new in terms of this capstone project. So as you might, as I think we are all aware that extending the use of green energy sources such as wind power, has become a matter of human survival on this planet. And so extending the use of wind power results naturally in new challenges, so that need to be resolved. One of the biggest challenges is that wind power is not always available. So depending on the presence of wind, so as a natural resource, wind is not always there, right? So in the face of natural wind fluctuations, also the electrical power grid, depending on the power supply from the wind, the electrical power grid needs to be kept stable. So this is a challenge. The more we are dependent on green energy sources as wind, the bigger this challenge becomes. And this was actually the background and the motivation for the current project I'm presenting to you, namely to harvest atmospheric forecasts to predict wind power. So in my current capstone project, I will follow the idea to use atmospheric forecasts for selected locations. So I just picked 3 locations to bring up the example, to use the atmospheric forecast to predict fluctuations in wind power. And these fluctuations in turn could be used to model wind energy production ahead of time. And so this knowledge, so using weather predictions to predict these wind fluctuations, and using this knowledge could to increase the stability of electrical power grids. So that's the big motivation behind the current data engineering project. And I will have some opportunity to investigate aspects of this assumption, not completely, because I think the focus of the project is the data engineering part. So with this background, let's dive into some specific details of the project setup I chose to prepare. So the objective was to provide wind records or wind profiles from different stations via API connection. So this was the data streaming part, because the API connection was in real time. And these records are processed and analyzed as historic data. So these are the past weather predictions, and live feed data, which represent the most recent samples. So this was in terms of the objective. So in terms of consumption, we have an imaginary wind power energy company which will receive this data via a BI tool or a dashboard, and they should be able to first analyze the predicted wind profiles for different locations, namely this historic data. Then the second point is crucial to evaluate these predictions and the quality of these predictions, which is just the difference between the actual weather at a certain date and the difference between the actual weather and the predicted weather, and to express this as the mean squared prediction error, which is a quite common measure to assess the quality of the prediction, and to monitor the live feed of the data, namely if are the data still coming in. So these are the 3 aspects the wind power company would like to evaluate in this scenario. So I'm trying to continue here with my presentation. But okay, then let me just change this to here. I guess you still can see the presentation is big enough, right?
Yeah, that's
yes, okay,
fine.
cool. Okay, so as a data source, as a data source, I used the following, namely an open API that offers hourly 7-day forecasts for more than 5 national weather networks. including US, Canada, Germany, and France. They're combining local and global weather models. And the relevant measures I was interested in for defining these wind profiles were air temperature, wind speed, wind gust, atmospheric pressure, and so on. And this kind of input can be used to calculate wind power energy production. For example, I have shown you here in the slide, there's actually a library for Python in order to calculate wind power energy production. And on the right side, you see actually the whole context. So estimating wind energy production is a big thing anyway, and a lot of pre-work has been done. So the simple idea here is to change the actual weather conditions with the predicted weather conditions, and to use this in the same model setup. For example, I mean, this paper I'm representing to you as an example uses a neural network to model the wind power production. And so why using predicted weather conditions? Again, the rationale behind this is if these model inputs can be taken from a weather predictions within reasonable error bounds, wind energy production could be estimated ahead of time, but of course only for the near future, because I think the most accurate weather models are just in between 4 or 5 days with a reasonable prediction error. So this is the topic relevance and the idea behind this project. And now I would like to show you the solution architecture, how to make this happen. So we have in terms of source, ingestion, transformation, storage, and data delivery, different tools and setups. I explained that we are using a REST API from the meteorological stations in order to get this weather data. We have a real-time data ingestion based on a Kafka topic. And from there, we split in 2 areas, in 2 warehouses. First, for the historic data, this OLAP warehouse, and for the real-time data, the real-time data warehouse. And both warehouses are connected to the dashboards. So the dashboards is consolidating real-time data and historic data. And you could see that for the tooling, I think the usual candidates which come into play. So using on Confluent Cloud, using an HTTP source connector to get the API data into a Kafka topic for the real-time data ingestion, and then having the API source connectors in place, each having one Kafka topic connected to. I'm using the ksqlDB to combine each different Kafka topic into one single data stream. Why? Because this is more convenient, because this one unified data stream I can forward into both warehouses, for the real-time data warehouse, which is hosted by Clickhouse, and the data warehouse of Snowflake, which is combined with dbt to do the data modeling, and then going through raw staging serving layers, and the serving layer is connected to the dashboard. The same goes for Clickhouse, and preset unifies the data delivery. And now I just so I showed you now the whole setup, the whole solution architecture, and the data flow. And now I would like to jump into certain aspects that might be of interest to you. How I have implemented the specific solution for each spot. So about the API requests, there were different, there were separate API requests, each API request for a certain location defined with geological length and latitude. Actually, the meteorological models have a refresh rate of 180 minutes to 360 minutes. So every 3 or 6 hours per day. Since the API request only allowed one certain location, I had to connect 3 source connectors. And as I have shortly mentioned before, and without getting into all the nitty-gritties, you could see for each timestamp for each API for each location, I get a different time point. I get for every time point a prediction for different measures, including atmospheric measure, pressure, wind speed, wind direction, and so on and so forth. So for for 7 days, for the current date of 7 days in the future, so 8 times 24, because for each hour, and you could see that this very fast multiplies to very big data amounts. You could this is the data which responded which coming from the API are in JSON, so they are heavily nested JSON format. That's a pain, but I think everybody working in data engineering knows about the pain of unpacking JSON files. Yeah, so I had to go through this pain. Another aspect is the ksqlDB. I shortly mentioned that I have now 3 Kafka topics, each topic for each location of API requests from a certain meteorological weather station. And I wanted to join them in one stream because to make the data engineering for the data warehouses easier. So the 3 steps which I had to follow is first to create a single stream for each topic, then create a unified stream, and then to insert into this unified stream. And this all done within the ksqlDB. And then we have only one topic. This is the stream, the overall stream, that's the output. And actually it's too small to see, but you could see the ID of the location that is three times different, right? Yes, but I will show you in the dashboard later, so that you can trust me that this aspect worked. In the end, in terms of Confluent, we have source and sync connectors, right? So we have these 3 source connectors, which are HTTP source connectors for the API, and then we have 2 sync connectors: the Clickhouse sync connector and the Snowflake sync connector. In terms of modeling, we are here in this diagram. In terms of modeling, I used DBD models, and they had different levels to work through the data. So the source level is about definitions of the source table columns and testing. Staging level is about unnesting the JSON file and doing the correct date time formatting, which will be used later for calculating the statistics, which is done at the serving level. So calculate the averages and mean squared prediction errors, right? Which I promised, because the idea was to investigate the difference between the predicted value and the actual value of a certain weather measure. And this is done on this serving level. And then I calculated summary statistics for all measurement times this means wind speed, temperature at different altitudes, and so forth. And then, of course, deduplication, so that we only provide data that are ready to consume within a dashboard. To show you now the results briefly, here in the presentation. So the dashboard contains several sections, each reflecting different data aspects. And this is the first one, which is actually the status of the API requests. And you could see that we have actually 3 locations here, right? What I promised here in the beginning of the in the beginning when I tried the testing, I only did it for 1 location. When I was sure that it worked, you could see that the rest are coming in, so that the difference should be every 3 to 6 hours. Then actually the hypothetical wind company can come in, since it's a live data feed, could see when was the last timestamp, are the data really fresh coming in from all the 3 locations which are investigated. Now, coming to the summary statistics of wind speed, you could see the wind speed for 10 meter above ground, for wind speed for 80 meters above ground. Here the column is for each location. So we have location 1, 2, and 3. And it sticks already in your eye that the location number 2 is quite ahead in terms of average wind speed in comparison to all the rest of the locations, which is quite interesting because these locations are just 25 kilometers distant from each other, and they are clearly different in terms of predictions. Now we are asking, we need to ask ourselves, actually, are the predictions accurate? How accurate are they? And therefore, I just plotted for you the temperature predictions. First, let's have a look on these fluctuations here above. So these are, you can see that it's a joint plot, right? Here is the temperature plot in degrees Celsius, and the second y-axis is actually the mean standard prediction error, right? This refers to these lines here. And first, let's just go to the temperatures to see the nice changes between all 3 locations between day and night. So it's quite plausible and quite rhythmic. And then you can see the prediction error kicking in. The prediction error are clearly there. There's an offset, but the differences between the locations can be also clearly seen, that some locations can be better predicted than the others, and that's the main outcome. Why in the end the prediction error gets bigger and bigger is associated with the availability of data, because we have a sliding data window, and in the beginning we have more data than at the end. So actually we would need to run this for several days ahead of time in order to have a convergence of the data predictions. Now I could now quickly show you the Snowflake, Clickhouse, and preset data dashboard. I just have a look on the actually.
Sorry, Gernot, I don't think we have time.
Out of time, right?
Yeah.
I guess so. So I will just skip around the lessons learned then. So actually, nested JSON can be nasty, but I think everybody of us experienced this already. The flattening can be dangerous, can lead to data explosions. Learned this myself. Sanity checks are important. So about the data volumes need to be checked frequently, and SQL window functions can be a great friend. And that's basically it. So I just want to thank Jonathan and Henji for their enduring support during realizing this project, and all my classmates and the rest of the DBC team. So thanks a lot for having me.
Awesome. Thank you, Gernot. All right. Round of applause for you, Gernot. Great job. We're going to open up the floor for questions in a second, but I will say quickly that Gernot had a lot more detail to actually go through that he didn't get a chance to, but we will be sharing links to Gernot's GitHub project if you'd like to take a look at the code that he's written to do all those data processing steps. So yeah, I guess now we'll open up the floor for questions. As before, if you have any questions or feedback, even feel free to unmute yourself and share your questions or feedback, or drop them in the Zoom chat as well if you like.
Great job, Gernot. I have one quick question, and that is, I was interested to see that you were showing a graph regarding how the predictions worked out with the actual results. So I'm curious to know, is that also part of data engineering, or you also incorporated data science into your project? I'm just trying to understand the difference between the two.
No, actually, I mean, sure. I mean, data science and getting insights out of data. I mean, that's where I come from. So that's really a motivation for me. And but the data engineering part, to a lot of extent, the data are not there to make the insights, to analyze data so that to get to the insights. So therefore, I think actually data engineering and data science are essential to be combined. And I tried this in baby steps, right? Because actually there are so many different details that have to be investigated, right? There are so many assumptions behind this project which have to be investigated properly, right? One is, for example, the modularity of weather models, right? Are they actually that accurate that they can separate 25-kilometer distance location? Do they have really that specific weather models, or they are all slided out and intervening? You know, if they are not that cut out, it doesn't make sense to model them separately, because basically they could be modeled at once. But the preliminary work I presented, it looks like that they are really different, right? The patterns are really different in terms of wind profiles. This can be quite readily shown. What I haven't showed you in the preset dashboard, what is surprising, that in terms of temperature and atmospheric pressure, for example, the predictions are quite accurate. So that the prediction area is not that far off. But for wind speed, for example, the differences are quite high. So therefore, there's a big doubt if this idea really goes through, because the wind speed is one prime data point for estimating wind power, right? Together with the wind direction. So therefore, I don't know if I really have answered your question, but there are many aspects that need to be answered, actually. And I try to engineer the data availability for answering these questions, but it's only the start, not the end. But I don't know.
I see. Great. Thank you.
Thank you.
We have time for maybe one more question.
And as Jonathan mentioned, of course, so I will publish this in a public GitHub repository, and happy also to if you go through different aspects and or have questions to email me anytime. I think we are connected anyway via DBC. Yeah.
Cool. All right, I think that's all. I don't see any other people raising questions. So thanks again, Gernot. Awesome work and well done.
Thank
with
you.
the presentation. Cool. All right. Last but not least, we have one more presenter up, and his name is Marc. So Marc, would you like to go ahead and kick off your presentations?
Yeah. Hi everyone. I will share my screen.
And you
So
could as well share your camera if that's possible.
okay, I will.
Thanks.
It's really late here. It's on 1 a.m.
Awesome. Thanks,
Okay.
Marc.
Hi. My name is Marc. I am part of this bootcamp. For this project, I will present my dashboard. I did this project because I was interested in the Premier League, and it's something that when I was young, I used to do a lot of betting. So I wanted to explore the possibility of doing analytics. And this is something that also I want to continue building in the future. In the last, we didn't have a lot of time to work on this project. We only have 1 or 2 weeks. So about myself, I did finance at university, so I don't have an engineering background like most of my colleagues. And prior to this bootcamp, I have only experience as data analyst. So most of the tools that I learned in this bootcamp, most of the tools that I will present in this project, I learned it in this bootcamp. Okay, so let's deep dive into my project. As I said, my goal was to build some ETL pipelines that would extract data from the Rapid API. The Rapid API, it's a API for the Premier Leagues that you can have data for anything, like the Champions League. You can have data also for each player, how many minutes played, for example, if this player is injured. Also, you can have about ranking of the team, information about the stadium and yellow card, so anything that you can think of. And as my colleague also said, that the data will be generated in JSON. About my data architecture, so for this project, I wanted to practice Snowflake and DBT. In project 2, the one I did before, I already did Databricks and data modeling. And I wanted to learn also, I wanted to practice Airflow because we learned Airflow in the last couple of weeks of the bootcamp. So I extract the data from the API in my case, and I load it into a data lake S3. The data I will be extracted, I will run my DAG every 24 hours in Airflow, and then my data will be loaded in JSON format, and then I will load it into Snowflake using the S3 to Snowflake operator in Airflow. Airflow will be, first of all, I would do everything locally, but because Airflow consumes like 5 GB of memory in your computer, so if you have a small computer, it's not the best thing to do. It takes a lot of time. So I would run then Airflow on an EC2 in AWS. And in Snowflake, also, I would use dbt to run on top of Snowflake. I would have a bronze, silver, and gold layer in dbt. And where I would do some transformation, I will talk later on. And I will use Apache Superset for visualization. Apache Superset is a free tool, very easy to use compared to, for example, Tableau. I think it's not free. So the first step in my project is to run, as I said, Airflow locally. So Airflow is take a lot of memory, and for Airflow to run locally, you have to config. You have to change to play a bit with the config. So you need to have a DAG folder, and everything you have to write your code inside the stack folder. This is my structure in GitHub to running the DAG, and this is also my dbt, which is in parallel of Airflow. So first of all, you have to create your variable. I use the Airflow UI to create my variable. Instead, in previous project, we have used environmental variable, but we can use the Airflow UI. And also I created connection from the Airflow UI as well. So we need a connection to Snowflake and a connection to AWS S3. So the first step of my pipeline is to extract and load to S3. It's very it's not really hard to do, but you need to play a bit with the Python operator, and then you have to use the AWS S3 hook operator with all the variable and the connections that I created before. Then the second step of my project was to create the resource in Snowflake. I decided to use Snowflake for this project because Snowflake use auto scaling and separate compute and storage. Also, I wanted to practice connecting Snowflake to S3 and also running DBT on a regular interval. So I created a warehouse with the smallest possible because I don't have a lot of data. And then I use the S3 to Snowflake operator to transfer the data from S3 in JSON format to Snowflake, and then I wanted to practice idempotence. Idempotence is a concept where every time that you run your DAG, at every time you should expect the same result to happen. But I thought before starting the project that this operator would have a start date and end date, but it didn't have. So I could avoid this step of S3. So because of this, I would have, let's say I want to check the ranking for Arsenal. My row table would have Arsenal every day and the ranking, but it's not something that I want to see in the gold table. So that is why I have to do some transformation in DBT. So some transformation I do in DBT would be, first of all, to transform my JSON to table, to column, and then I would have to rename some column. And I did some testing in DBT, like generic test. And one generic test I did, like I made sure that no team play more than 38 game, for example, and some data quality tests, like for example, that every team we have 20 team that play each time. So this is about my DBT, and then for DBT to be in production, we need to create a Docker image. Here you can use also DBT Cloud, but I preferred to use AWS. So I run my DBT in a ECS cluster, like Eric has demonstrated before. And the last step in my project would be to convert all these steps together to run my 3-step of my DAG independently. So for this, I couldn't done it locally. I couldn't have. So I decided to host Airflow on EC2. And there are several steps to do it. First of all, I have to push my code locally to GitHub, and then I have to create my EC2 instance. EC2 instance. So here you have to bear in mind that it costs some money to run this project. For every hour, you will be charged money. And then I would have to, inside my GitHub, I have my Docker file for my Airflow that I run locally. I would do a git pull. I would do a Docker run, I mean. Yeah, this is how I run Airflow. I would show you how it looks like. And 1 second, so I'll show you. So this is my Airflow. It's not really, but if I run my DAG, it should not take a lot of time. But if you would try to run this locally, it would take maybe 5 or 6 minutes. Let me check. Hopefully. It takes some time. yeah, as you can see, it is running. And my preset dashboard, it's very simple. It's just I didn't have time to do more sources. So you can see that Manchester City has the first, and the player was a multi-layer card, and also a map of the stadium and the capacity of each stadium. But yeah, so these are my different steps from my DAG, like the extract ranking, extract yellow cards, and my copy from to Snowflake, and my DBT transform. So my preset connection, you have to connect DBT to your so Snowflake. You have to connect Snowflake to preset. This is how you do it. You need to create a network policy inside Snowflake to allow preset to connect. And finally, the lesson learned, as Eric mentioned before, you have to make sure you know what you extract from the beginning. And as I said, my goal from the beginning was to learn how to deploy Airflow on EC2, and I think I succeeded. And I wanted to practice Snowflake because it's very important. I think it's the most used data warehouse nowadays. And also I learned how Airflow can connect to the different services like ECS, for example. And some improvement for my project. The S3 step is optional because the data is very small currently. So you could have gone directly from the extraction to Snowflake directly, or you can even load the data to PostgreSQL. And also, in the future, I want to also, if I had more time, I would use CI. I would use linting, or I would use dbt test to run whenever I do a push. Whenever I want to do a push request, I wanted my code to be tested before I can. And I would like to use Terraform to create all the infrastructure that I did, like creating the S3 bucket. I did manually, but in real life, I would use Terraform. Some of our team member use Terraform for their project. And yeah, that's it.
Awesome. Great work, Mark. Round of applause for Mark, everyone. Thanks for sharing your project. A quick question from me before we open up questions to the floor. Have you used any of your analysis that you've done for any sports betting?
I didn't do spot betting for a while now, but I plan to do in the future. I plan to continue on this project later on, of course.
Very nice. Yeah, if anyone would like, again, to ask any questions, feel free to unmute yourself and ask questions, or drop your questions in the chat. If there are no questions, I did have one question. So why did you use Airflow to do the data ingestion? Could you have used something like Airbyte instead?
Yeah, I could have used Airbyte, but Airbyte maybe would have been better, but I wanted to practice Airflow for this and the Python operator.
Cool, thank you. All right, if there are no other questions, then we'll jump into networking. So I'm just going to share my screen here. All right, so once again, just a massive congratulations to the 3 presenters today. We will be sharing their links to the projects via email after this session. So we'll jump into a time of networking now. I'll hand it over to Douglas to facilitate that.
Hi, everyone. Thanks for the presentations, Eric, Gernot, and Mark. Great job. We're going to jump into a few rounds of speed networking. So it's quick, we're doing 3 5-minute rounds of randomly allocated groups. It's a great opportunity to pull industry knowledge, potentially collaborate with other people and look at partnerships or other projects, and even career advancements as well. Now, instead of the 3 iterations, we're just going to do 2 5-minute rooms. You'll be spread out into the breakout rooms randomly, and there'll be a topic for discussion that's broadcasted. The first topic is, what do you think are the most popular and your favorite data engineering tools and why? So we'll move into a few rooms and then we can get started.
Oh, the rooms are now open. You should see a link you can click on to join the rooms. All right, I might wrap it up here. So, James, do you have any things you want to say to wrap up the networking discussions?
Yeah, I had a question about, probably to you or anyone else who has experience in the field. DigitalOcean is an alternative to some of the big 3 cloud providers. I want to know if you have seen any uptick in popularity for it, or if you think that it'll just be acquired or even beaten by big 3.
I would say, to be honest, I haven't used much DigitalOcean, so I can't really comment as to like whether or not it's going to be acquired, or and like whether it could replace stuff that the 3 cloud providers are doing. I guess my understanding of DigitalOcean is that they kind of focus more on the PaaS side of things, and by PaaS I mean platform as a service. So like if you want to run a database, you just a few clicks and you've got a database going. But they don't do the lower level stuff like IaaS or infrastructure as a service. So like they don't do, like, as far as I'm aware, they don't do like deep low level stuff like creating a network, creating a virtual network, a VPC, subnet groups, stuff like that. I'm not sure how far they go to with like their EC2 instance equivalents as well. They probably have those, but I'm just not sure much. So long story short, the answer is I don't know whether or not they're going to be acquired or could replace the big 3 cloud providers. I definitely see like they lacking some services. Like Amazon has things like SageMaker, Azure has Azure ML, so they offer a bit more than just like cloud resources. Yeah, don't know. Does that answer your question, James? Cool. All right, Douglas, you want to wrap us up?
Yeah, sure. Thanks everyone for coming through. Seems like a few people have dropped off with the evening going closer to the networking, but appreciate it. Thanks for everyone that presented as well. That's great. And looking forward to seeing the next one as well. We'll stay in touch. Everyone will be emailed out the GitHub links so you can view those as well and get the deep dive behind the projects if you want.
Alrighty. Thanks, folks.
Cool.
We'll see you next time.
Thank you.
Thank
Goodbye
you.
and cheers to everybody.
Thanks. Cheers all.
All right. Have a good evening.
Yes. Yeah, good evening.
Good night. Good day.